Hello everyone. Today in this video, I want to talk about reading XADC data via the PS unit. Um, and this is the second method for reading data from XADCs. Don't forget to visit my channel that I have provided here in order to find other tutorial regarding the SoC design, and especially my previous video, which I could tell you it was a hardware based XADC test, which I name it as method 1, and it was a little simpler than the method that I am trying to explain in this video, and the address of this video is provided here. By clicking on that, you could directly go to the page of the tutorial related to the method 1 for reading the XADC data. The objective of this method is to read the data related to the on-chip temperature and voltage sensors using the processing system, the PS I mean, and to display the measured values through the serial board at 1 second interval. Step by step in the next part of the video, I will show you how you could complete the project in this regard. Okay, for doing this project, I can create project. Name is as XADC. Method 2. The next, boards, Zybo, then finish. Then create block design, no change. Okay, go to the add IP, then search for Zinc 7 processing system and add it to your project. Double click on this IP block. In the setting, go to PSPL configuration tab and then choose XI non-secure enablement, GP master XI interface, and unchecking this option. Then confirm this page, and as you could see, this master XI port has been disappeared. Then go to run block automation. Okay, then go to sources tab, right click on this design one, block design, create a HD wrapper. Okay, then go again to Fellow Navigator and scroll it down, generate beta string. Okay, after beta stream generation become completed, you could cancel this page and then go to File, Export Hardware, and check this one to include beta string while exporting the hardware. Okay. And after exporting, you have to go to Launch SDK. The SDK starts opening. You should wait for that. Okay, then in SDK, navigate to the File menu, choose New, and create a new application project. I will name it as XADC PS. And because I already started the SDK, I have the option to create a board support package before I start creating a new application project. But now, because I started from creating the application project, I don't have an existing board support package, so I will choose create a new board support package. And the name most of the time will be the project name that you already given to this field, and with underline, and with the index of BSP, which is the abbreviation for the board support package. Okay, I will choose next with this option, and then finally choose npt application in order to create a new application project with a new board support package related to that. Then go to the project explorer, and then the subfolder of XADC PS board support package, and then open this system.mss file. Okay, this file contains information related to drivers, different documentation, and their associated examples. As you could see, there are some examples related to different drivers like DMA, Ethernet, or other configuration that you have done in Vivado, and also, for example, some documentation related to DDR. Okay, as indicated in this figure, because we wanted to do a project related to the XADC, I have to scroll it down and then find this XADC, and then click on this import example. It is very helpful if you want to use these examples and get idea from them in order to complete the project, but otherwise you could cancel this page and write your code by yourself. Okay, and also in another part, by navigating again to the project explorer, and then XADC board support package, and then PS7 Cortex A9 include folder, it's also possible to access the libraries that have been created by various drivers. In this project, two libraries, XADC PS-HW, this one, and also XADC PS.H, this one, are required, and these libraries define important functions that are used to communicate with the XADC, read voltage and temperature sensor data, and perform various configuration tasks. By having all this knowledge, I will go to the next step of creating the main.c code that is required as a main function in this example. Okay, I will open this one again by right-clicking on src. I will create a new source file. I will name it as main.c. I will complete the code and save it. Okay, the code is so simple. It initializes the XADC peripheral in the zinc processing system and continuously reads the internal temperature and various on-chip supply voltage. The raw ADC values are converted into physical units, degree centigrade and volts, using XADC driver function, and printed to the serial terminal once every second. Specifically, the code reads chip temperature, VCC internal, VCC auxiliary, VRAM, VCC P internal, and VCC P auxiliary, and also VCC P DRO. The function that it used for reading this data is XADC PS get ADC data and converts them with XADC PS raw to temperature. And this one is raw to voltage, and if you look at the code, you could see that after getting the temperature data with using XADC PS raw to temperature, it will also convert it to the temperature. I will provide you the GitHub repository address in the description of this video in order to be able to access to this main.c code that we already written here. After that, you have to connect the board to the PC and turn it on. Then you have to go to run configuration. Okay, by creating a new one, by choosing the beta stream file, then initialization file, then choose reset entire system, and then application, which is PS7 Cortex A9, and there is no other required change here, and then apply this one, and then go to the SDK terminal. You could close this one, go to SDK terminal, add the COM port, which is only one option, COM4. Baud rate is 115,200. Then click on OK. Then COM4 your port is connected here to this SDK terminal, and then again go to run configuration, or you could run it directly. Choose this one that you have already generated and then run. Okay, if you check the SDK terminal, you could see that all the variable, for example, VCC auxiliary and the temperature and the internal voltages will be printed in the SDK terminal of the SDK. Okay, this video has been finished, and this one was the next method and the second method that we have for reading the XADC data, the IP block, and that is available on the PL side of the Zinc 7000. Goodbye for now, and wait for another video for method 3 that I will put it in my YouTube channel.